Great. Our final speaker in this session is David Hay. David's a longtime administrator of all things Linux and storage. He ties the room together as a cluster engineer at LINBIT. David started out with the Linux back in the 2.4 kernel days, and since then he's been planned and implemented countless clustered systems, both large and small, leveraging HA and cloud technologies to great effect. When not liberating the enterprise world with free and open software, he spends his time tinkering with electronics and metalworking. David.
Thank you. It's a pleasure to be here. So as we're here, we're talking about all of these wonderful storage technologies that we can put. What do we do with all of those technologies? How do we bring them to our application? And doing that with software-defined storage is a way to do that in a data center that doesn't involve a huge amount of manual tinkering. So when we begin to talk about that with storage and with Linux, well, Linux already has a lot of utilities to do that. For example, the logical volume manager, RAID, caching. All of these things happen on the block level. And all of these things can be tied together in their own way. So as a first building block, we typically think about LVM when we think about Linux. LVM is, you can think of it as an advanced partition table. It allows you to wrangle all those physical devices that you have in a particular node and arbitrarily cut them up into smaller, larger block devices. It has a lot of its own flexibility that allows it to be used nearly anywhere. If we look at this fairly simple model here, you'll see that multiple physical volumes, multiple disks, can be pooled together and placed into logical volumes, which themselves just look like normal block devices. Later on, in LVM, we actually added the thin LVM layer, which allows for continuous snapshots and long chains. And this begins to form the building blocks of what might be a very useful storage product for software-defined storage, as it's so easy to control. In addition to that, we have the software RAID functionality that's been around in Linux for quite some time. Fairly recently, in the last few years, this has been integrated into LVM. So LVM now has the ability to not only pool devices together, but also define how many replicas you may want in that pool per volume. So those together already form a very useful building block. And on top of that, we have SSD caching. SSD caching currently in Linux has about 2 implementations that are roughly similar in performance, with bcache pulling ahead. While dmcache is actually able to be used with LVM natively, bcache is also just another block device, and we can stack these on top of each other as much as we'd like. Of particular interest is the recent ability to deduplicate our data inline. And this is done using the recent edition of VDO, and Louis Emmershine will be talking about that later, so we don't have to cover that extensively. But the most important thing to consider when we're talking about deduplication is that this is inline. We didn't used to have inline, especially not at the block level, and not in Linux natively. So this would allow us to have a very powerful data deduplication technology and can save a significant amount of money. So while we have all of these building blocks for block-based storage in Linux, we also have the ability to export it in a lot of wonderful ways. There's a lot of them that are mostly historical, like the IETD and ST, but LIO is the current iSCSI target. It does a lot more than iSCSI too. It handles many other fabrics. And LIO would just be Linux IO, all that stands for. In addition to that, we also have the ability to export with nvme-of fabrics, which is, well, pretty exciting. So we have a lot of ability to export these block devices that we can chain together and build arbitrarily within Linux, already in the kernel. We don't need to add anything for this. So now that we have considered some of these building blocks, let's talk about maybe replicating that data, because so far all of this data is still on one node. It's not highly available. So DRBD is a technology that allows us to asynchronously or synchronously replicate data from one node to another in line. And it follows a primary-secondary relationship with replication occurring during write. Say I can write to one node, and another node will receive that write and then acknowledge it. And then this data has been written. So it's extremely cohesive. And in recent versions, we have the ability to have up to 32 replicas. That may seem like a lot, but we also have the ability to connect to over 1,024 nodes per resource. So while we can write our data out in triplicate to many nodes over TCP, over RDMA, over many other things, we also have the ability to write diskless. This is particularly interesting because this is effectively an iSCSI replacement. This allows us to have truly highly available targets, and our targets are these secondary nodes with data. This condition can happen essentially by accident if you were to lose a disk within a 3-replica system. And you would say that this is now unintentionally diskless, and we now need to repair this while it still accesses these 2 replicas over the network. But of course, we can't do this on purpose. So if we want to have diskless nodes, if we want to have compute nodes separate from storage, we can have many different ways of forming our storage, whether they be hyper-converged or composable. We don't need to focus too much on that. So with the ability to manage our volumes like this, with the ability to stack deduplication, caching, any of these other features, and all of those have separate control planes. All of those have separate command structures. They're all of themselves somewhat difficult to control and would take a lot of knowledge, and in addition to, well, just being a lot of hand-holding for the technology itself. So wrapping that up to a software-defined storage system is our general goal. So what we want to do is be able to build these things from generic nodes, to be able to throw whatever hardware you want at this and say, I would like to have X amount of replicas with these features, and I would like to be able to export it to OpenStack Cinder or Kubernetes as volumes, as managed by Cinder and Kubernetes, rather than having to manage it yourself. So with all of those technologies that we've seen before, we do have the multiple deployment architectures. We do have very, very distinct abilities to be very flexible because we're controlling LVM. We're optionally controlling ZFS as well. And we can have multiple volume groups within LVM. This allows us to have multiple pools of physical devices, so we can classify them now. We can say that this pool is fast, this pool is slow, this is NVMe. And we can export them using DRBD, using essentially a network RAID block device to whatever host we like over extremely fast InfiniBand links, for example. We can have very low latency and very high flexibility. And in addition to that, we can also control nvme-of through Swordfish. So we can have a more universal control plane for our data center. LINSTOR itself has a great architecture in that its control plane and data planes are completely separate. The data planes that we're talking about are the pieces that we've just discussed before with LVM and DRBD, all those things. They're controlled by the LINSTOR satellites. So the LINSTOR satellites are stateless applications that will run on these nodes, that will send the commands to create those block abstractions. But if that controller goes down, or if those satellites go down, your data remains. Everything will still work. So if you have a LINSTOR controller go down, the satellites will continue to function. If one of the satellites goes down, the block devices will still continue to function. So this is a completely separate control and data system. And the controller itself can interface with OpenStack, Kubernetes, and various other cloud platforms. More will be added as time goes forward. So what we see here is a very simple example of what we could do with LINSTOR with the replicated volume and with LVM. And this is an example in which we have a workload here that is actually working on a replica 3 volume across many hosts, or a workload here that's created in a replica 2. And we can choose this upon creation. We can just say that I want 2 copies of my data, please distribute them to my storage cluster. And that storage cluster may be on your compute nodes. But because DRBD has the ability to replicate data, we can also move it off of our compute nodes without ever taking it offline. So if we want to move from a hyper-converged infrastructure over to something a little more disaggregated, we don't have to take everything down. We can actually make decisions in our infrastructure that we don't really have to worry about changing later on, because we can actually create entirely new storage stacks underneath that replication and say, oh, I want to add VDO underneath. Oh, and I don't want to get rid of any of my data, and I don't want any downtime, so let's just move over to a VDO system over on this other machine using DRBD's replication. LINSTOR itself, we actually have the Swordfish API. This is functioning for access for nvme-of. What we are very looking forward to is DRBD proxy for a DR product. So while DRBD itself, its replication can be asynchronous, it's still limited by the TCP buffers when trying to disaggregate, decouple latency and network latency and disk latency. So proxy is a product that will allow you to essentially buffer those changes in memory over a longer period of time. As you can see, our northbound drivers, we've done a lot of work into that with Kubernetes, OpenStack, OpenNebula, Proxmox, and coming up Zen Server. Thank you very much. Do you have any questions?
Any questions?
Very well, thank you.
Yeah, why don't you go ahead and stay up there if you could, David.
Sure.
Yeah, let's see. So there's a lot happening in the open source world, and so I'm just a little curious with regard to what's next for LINBIT. I mean, you talked a little bit about some of that, but how about the longer time frame? Like, how do you see yourselves expanding the infrastructure and the impact of open source on a lot of the players out there?
Well, there are a few other products that try to accomplish the same thing with software-defined storage, but a lot of them are not open source. So I think one of the critical components of what we're doing is that what we're using here is already in Linux. It's evangelizing Linux. It's using these components that we already know to be so reliable and that we already trust in our machines, and bringing them to the data center, and potentially in enterprise replacements, but in many scenarios. So what I see as a future is likely creating a more universal control plane in our data center that's centered around open source, it's centered around Linux. And if we can do that, if we can leverage things like Swordfish, if we can have a truly API-driven infrastructure, then we can change the way that we actually use our data centers to use everything through APIs, rather than having this separate product to do this and this separate product to do this. Everything is much easier to put together. So, as far as what it looks like in the future, it looks like what we've been doing in the past, and that we've been combining all of these other technologies together in just totally arbitrary stacks, but without having to make all this glue, where we can just put it together easily. So everything is getting easier. And that's what I see. I see it making things easier.
So do you see like the major players out there? I know IBM has long been part of proponent of open source. Do you see pretty much the major players out there embracing this, or where do you see the sticking points with regard to open source having a greater impact on the storage industry?
Well, as far as big players are concerned, there's a significant interest around around open source and software-defined storage. So I would expect that to continue. As far as big players are concerned and using this technology, I think was a little hard to predict for myself. But I think what we'll see is probably a more of a shift towards these disaggregated solutions rather than centralized solutions, rather than centralized proprietary solutions. So as far as having a big vendor interested in that, well, that could translate to a cheaper data center very easily, and it already does. So there's a certain element of cost that's a good driver for that. And as far as predicting the future, my colleague Greg is a little better at that than I am.
Great. Well, thank you very much.
Thank you.
Yeah. So let's see. So any other comments on some of the talks we've heard so far from our panel? I mean, there's one of the common themes underlying all this has been standards, and there's people have been coming in from different directions, although obviously the bottom line is hardware that works together conveniently for the user. So any comments? So Rochelle, with regard to, for example, Swordfish, we saw LINBIT is obviously embraced that, and that's part of their infrastructure. What other players in the open source world are you guys working with at SNIA in that regard?
Well, one of the things we're doing differently with regard to open source is with both Redfish and Swordfish in DMTF and SNIA is almost all of the tools are available via open source from both DMTF and SNIA. And so if you go to github.com/DMTF and github.com/SNIA, you will actually find a whole bunch of tools to support Redfish and Swordfish. And if you look at who has developed those tools, it's been Intel contributed, HP contributed, Dell contributed. So a lot of the big companies working on this, the ones that are all in the middle of the list, have actually been contributing open source to support the adoption and development of standards. Now, in terms of companies also working with that, we see integrations. So Microsoft has been pushing things like their what's it called, Windows Admin Center. Is now completely in the open source space. So for someone to develop an integration into Redfish and Swordfish, it could be a Microsoft employee, or it could be anyone could just go out and develop an integration into their Windows Admin Center. So that could literally show up any day. And so we're seeing a lot of transitions in how people are making integrations available. OpenStack is obviously another area that's just available for open source, and what we expect to see there is, because we're doing REST to REST this time instead of REST to what everybody's proprietary APIs, we expect to see both Redfish and Swordfish work much more seamlessly with OpenStack than previous versions of APIs. There's a Redfish integration being developed right now for Ironic, and as soon as that's in place, we'll look at what storage extensions make sense for both bare metal with Ironic for direct attach and configurations, and then what do we need to do for Cinder and for Manila. So we expect those to be coming in 2019. So those are just a few of the places that we see open source a lot differently from previous standards.
Mm-hmm. How about, do you think with Microsoft's purchase of GitHub that it's on the verge right now, do you see any impact with that? I mean, obviously Microsoft is already in that open source world, but any perspectives on that or thoughts?
Well,
that you can say publicly.
We haven't seen a lot of differences. Well, the Windows Admin Center was one that, we do see Windows shifting for their use, but I haven't seen, other than, it's obviously something that we've been using extensively for years for both the development of Redfish and Swordfish. Another thing that we're doing is looking at, so our we have some other APIs that we're moving, or some other standards that we're moving entirely into the open source domain. So the CDMI spec has moved from a SNIA developed internal spec to an entirely open source spec. And so we're looking at whether that's something that makes sense for other specs as well. Which is it's definitely a different model.
Yeah.
And that's something that every company's going to have to look at from an IP perspective and make sure that they support. So it'll take us a little bit of time to get through.
So David, do you have any thoughts on that? Because you're obviously right in the thick of things with the open source world with regard to Microsoft, and they're maybe playing a bigger role in that. Do you have any thoughts on that?
With the increasing trend of essentially more pluggable infrastructure of rest to rest, I find that a lot of that is making innovation more efficient. Particularly as far as LINBIT's involvement in it, or as an involvement of Linux in that, that would seem to be an ongoing trend towards more generic, composable data centers and other technologies that will allow us to actually create more using the knowledge that we already have, using the effort that we've already put into things. So in the past, whenever we've been actually making all these products that we've been having to plug into each other, that we having to glue into each other, there's been a lot of inefficiency. So this brings us closer to efficiency. And if that's a goal, that's a good one, because we need that. So as far as how that involves with like a big player like Microsoft, or where they're open sourcing their significant efforts and allowing us to plug in what we've already made and what we could easily make into that, I think that's an extremely positive thing that we should embrace in as many ways as we can, especially to encourage more of that behavior, so that we can have technologies and centers that we can easily innovate in, rather than it being so thick.
So have the PlugFest been going smoother over the years, would you say? Because the greater infiltration, shall we say, of the, so to speak, of the open source world?
Yeah, it's gotten continuously easier. Everything has, that's, well, as far as Linux is concerned, as far as open source is concerned, there have been significant inroads towards combining and stacking all of these things that we've been making, and making them more accessible through things like REST interfaces, through things like stateless applications, through high-quality deployment systems. All of these technologies are generally there to make life easier for people, and we continue to do that by making technology that makes sense to put together, rather than having to reinvent the wheel over and over again.
So Chet, with regard to the SCSI Trade Association, what impact have you seen open source having on efforts you guys are working on? Is that a hard question to answer?
Yeah, that's probably a tough one for me. I'm on the hardware side, so yeah, I really don't have any.
Yeah.
Sorry, yeah, that's a tough one for me, but I probably don't have the right feedback for you.
Well, Justin, you work a lot at, with PCI SIG, you guys have PlugFest, and you were talking about that in one of your charts. What do you see the impact of the open source world on your PlugFests, for example? Or just anything you might want to say about the PlugFest in general as they progress over the years?
Well, I'll just say it's sort of with...
a little closer to the mic.
With standards, the PlugFests are really important, and basically the trust that the standard is being followed, and that we put to standards compliant things, they actually will do what is expected, which is that they just work. And so it's very important that these standards bodies, that they do have the PlugFests and the interop lists and things, both PCI SIG and NVMe have their integrators list. But yeah, I don't know if I can comment on how well the open source plays in on sort of the low level interfaces and things like that.
So from the software perspective, talking about like even the Redfish Plugfest, what we're seeing is, and more so the Redfish because they're a couple years further along, what I've seen even on the Plugfish side is people developing tiny little tools and publishing them as open source. So even if they're only used a little bit, people are still taking their tools and throwing them out as open source when they use it for the Plugfest, instead of running some proprietary little tool and then not sharing it outside the context of the Plugfest. It's just this culture that's developing, which is, hey, I wrote this tool, and instead of just sharing it inside the context of this group, they throw it out and throw it out on GitHub. And so it's definitely a mindset change that we're seeing because we started these whole programs around, we're going to share everything we can, and we're going to put them out on GitHub. We're going to make them available via open source.
Yeah, well, it certainly makes the things go smoother. I mean, if you've got a tool that you've used, and if you want to be interoperable with somebody else, they might as well use the same tool. I mean, obviously, it's for everybody's benefit in that regard. Yeah. So, with regard to the SaaS World chat, with NVMe beginning to make such a big impact, and the SaaS world having the traditional overhead of, basically the old model where it's been around for so many years. Does that basically mean things that use the SCSI command set with that model are kind of going away?
So, I mean, I think Justin mentioned it before. I mean, there's going to be an opportunity, depending on what the design requirements are, what the architecture looks like, that SaaS devices and PCIe products will continue to coexist in the marketplace. Not everybody's going to need high performance, high capacity, or high performance and low latencies. And so I think the infrastructure and the foundation for SaaS devices will continue to be around.
Alrighty. Justin, any other thoughts with regard to the PCIe world? I guess I'm just kind of blown away by this whole new model of putting storage directly on the bus like that. I mean, it's changing so many things. Had you guys been expecting such a big impact? I mean, I guess the NVMe-HCI first came out, I think, in 2009, and then NVMe was formalized, after that. Just any thoughts on that, your perspective, seeing that happen?
Well, I'll put on my Intel hat, and
okay.
The Intel hat was Intel would have liked to see even better adoption than what there is, but I think because there is sort of a lag between when the technology's there and it's working, when you start to see widespread adoption. There's sort of the inertia of a great technology that everyone knows, and they know the ins and outs of it, like SATA and SAS, and so just you can kind of take the lag of when one can sort of come at parity feature-wise, requirements, and trust-wise is kind of interesting, because when NVMe first came out, that spec was very lean and mean and simple. It was really just all about performance, but very light on manageability, logging, and a lot of the stuff that SAS does incredibly well. So there's certain enterprise storage applications that it's like I need my manageability, and I need to know all these other things. And the NVMe spec is starting to evolve. NVMe 1.3 and 4 and the NVMe-of, the manageability interface specification, starting to look a lot more like a lot of what's going on in SAS. And I definitely agree. I think there's going to be an overlap for quite a while. I think it'll get really interesting around for SAS 5 if NVMe is at feature parity and they both really require new silicon, new hardware. How much would you choose to do the new SaaS if you get performance benefits? And they are at the true feature parity. I think it's going to really depend on when that feature parity happens and how much time there is to maturity. So I think the next few years it's probably a pretty good bet. There's going to be all of this still going on, but after that it's going to get interesting.
Question from the audience here?
That's loud. When it comes to NVMe and management features, where do you feel, anyone on the panel, that there's the biggest gap right now? And whether it be something that's spec'd already and just isn't implemented, or whether it be something that's not even specified that you recognize the industry is wanting, where would you guys feel those gaps are?
One of the ways we're working to address that is that the NVMe Express group has the NVMe-of spec, which is looking at, basically the NVMe spec was, we want to be able to manage NVMe devices out of band, and so they developed the NVMe spec, but it's kind of off on its own, separate from a lot of the other manageability specs, Redfish and Swordfish that have developed. So we've actually developed a three-way alliance agreement, which is a new thing. Three-way alliance agreement is, I think this is the first one we've ever done as a three-way, between DMTF, SNIA, and NVMe Express, to basically see what we can do to close all the gaps in terms of what the functionality is, and then see if there's additional transports we need to develop to make sure we close what are all the manageability functions, or is there anything we need to do to align between what we have in Redfish and Swordfish and what we should put in NVMe, particularly the storage devices, but devices in general, and then how do we align the standards moving forward? So do we need to keep modifying NVMe, or is there something else we can do to kind of collapse those? So that's kind of the intent of that alliance agreement, is basically to address what you just said, which is, are there differences, are there things we need to do, and how do we manage NVMe devices moving forward?
So I have one, Rochelle. Can you talk, do you have any particular product implementations yet with Swordfish, or you think we're anything imminent coming that's going to actually use the synchronously?
So there are a lot of companies. So there's a lot of companies that are working on implementations. We had our first public array implementation, a flash-based array from a company called X10 that was announced at Flash Memory Summit. And then Intel RSD Rack Scale Design has had implementations. They announced, I think, in January, that has two sides. They both have an NVMe over fabrics as well as the pod manager. So we have both client and server and server side implementations from Intel.
Okay.
And then, as you heard, LINBIT, they've actually had announced on
I was going to ask about that.
Yeah, they've actually had on their website Swordfish coming for a while.
Okay.
So, I don't think shipping product yet, but
Shipping product, yes, is supporting it now.
okay, yeah.
Okay,
So-
because in August, I think you started shipping.
Yes.
Yes.
Okay.
And so I was actually going to ask about the timeline for that, because it's basically said coming soon on the website for a while.
Okay.
And those are the ones that have been announced and are shipping.
Thanks.
Anyone else?
So when will Swordfish, Kubernetes, SAS enclosures, SCSI enclosure services, all these things unify in one way, so we can manage storage at scale using, container metaphors, and it still feels like there is a lot of legacy that's holding the kind of view that David was putting forth, a very soft view of things.
Yeah. The transition is going to take a little while. You mentioned Kubernetes. One of the things we're doing is we're working another alliance agreement, and we're we're working with the OpenSDS folks, and right now they have a southbound API that's spec'd to be Swordfish, and we're actually working with them on a better integration of Swordfish on a northbound interface. And then looking to see if that's something, how we can develop an alliance agreement with the Linux Foundation to support that. And so that's all work in progress for us right now, is how can we basically, can we see if we can make that a Swordfish, native Swordfish as well. So I've mentioned like 5 or 6 things that are in progress, right? The OpenStack work, the OpenSDS, and on and on. So we've got a lot of stuff that's in progress now that we've got Swordfish in place. So some of it comes back to prioritization from vendors and things. What's the most important, right? LINBIT talked about integration into OpenStack. So we need some of our member companies to basically step up and say, these are the things that are most important. Right, we're very client-centric, and we need folks to kind of say these are the things that are most important. OpenSDS is one of our higher priority items right now because we have member companies, Intel and Huawei and Dell, that are all joint members of those, and we're all really focused on trying to get that alignment in place and get that OpenSDS and Kubernetes integration solidified and get that direction set.
And one more for David. We are starting to see a lot of embedded Linuxes as we try to do more clever things with intelligence close to data, something Manish and I will talk about shortly. So when you have a main Linux in or outside a node, trying to manage more distributed intelligence like several companies are talking about in SNIA Intelligent Storage and other groups, how do these abstractions or the deep stacks that you were talking about, how do they carry over when Linuxes need to peer and still deliver the same software abstraction stack? So if you have a Peta Linux running on a Xilinx ARM, and you have full Linux running on a main node, and your volume management going on the main node, but the Linux in the embedded side is doing something intelligent with the local block storage. What's the plan of the Linux instances? Do you want to look at this like a cluster, or do you want to look at them like a subsystem? What's the view that you guys take of it?
Okay. Depending on how I understand that, what the approach that many organizations would take would be the ability to continuously make decisions in that regard, to be able to address their infrastructure not only as this single unified cluster of components that one might use, but also to be able to scale each one of those components at different rates, and because of that, to be able to disaggregate those components. So, as from a software-defined storage perspective, that would mean exporting existing storage that we have on, say, totally separate nodes into other embedded nodes that may not have that capability, and making the export of that storage something that's a little more elegant than we may have seen in the past. So doing that with nvme over Fabric is as controlled by Swordfish, and Swordfish is controlled by LINSTOR, for example. So we can have these modular stacks of control planes that will allow us to essentially be able to make a more of a pluggable decision tree whenever we're talking about architecting our data center.
Let me have a quick follow-up for both you and Justin. So nvme over Fabric, for instance, right now has Ethernet bindings and Rocky and all these. Does it also have PCI bindings? So if I put an accelerator device with local storage, which is running its own Linux, and if you're advocating that the direction we should take is nvme over Fabric as the abstraction for collecting Linux instances together that have local storage, then should NVMe over Fabric have PCI bindings below?
Yeah, I'm not super familiar with the, I believe it's either a controller or there's some translation from nvme-of Fabric to the nvme-of PCIe. Yeah.
Yeah, there is a distinctly different method of communicating between PCI and NVMe over Fabric because we're sending messages when we're going over the network rather than and then scatter, gather, and things like that. So, as far as if there's bindings for PCI and well, for PCIe, yes, I mean that's internal to it. But as far as NVMe over Fabrics, we're not. I'm aware of at this time, not PCI Express. But there are some various extremely low latency fabrics that could be used. For example, when you brought up InfiniBand, or several other different systems. So.
All right, any other questions for the?
I want to ask a question myself. With this open source movement, things that you talked about, is there a measure, serious measure of how successful was the adoption? How many companies, not just the main sponsors who put in time and effort and money, but others, that's more important, particularly open source, and in terms of implementations, return on investments, anything serious on that than qualitative commentaries?
So the SNIA open source environment does require you to sign a contributor's license agreement in order to be able to do that. So we do have a way that we're tracking that. But GitHub also has mechanisms and insight, they call it insights, that allow you to basically go and see where all your contributors are coming from. And I don't know how often folks are actually going back and looking at it, but you can actually go and look and see where all your contributors. One of the things we're seeing is that a lot of the times when people are looking at swordfish materials and coming in and looking at the open source stuff, they're actually then turning around and joining SNIA to become more engaged and contribute. So we do actually have some metrics around that, right? So I mentioned X10 and LINBIT. We've talked about both of them. Both of them were non-SNIA members that have and external sources that both could have joined SNIA. So we talk about them as SNIA members, but they weren't a year ago. So from that perspective, we're seeing a lot of engagement from outside sources that are coming in. We've actually had multiple companies, a couple of companies in China as well, that were not members that have actually joined to get more information and get more engaged. So having a lot of this stuff available, not just through our normal SNIA sources, but available where we're seeing a lot of the draw from is, looking at tools and things we have available on the web and available through GitHub and having them engage that way is bringing them into the organization. And we know that some of the, I'm not naming names because I know some of these companies are actually working on implementations, so I wanted to mention that. We know they're working on implementations. They haven't announced anything yet, but we're seeing some of that pull in as well. So,
with regard to NVMe-of, as technical chair of Flash Memory Summit, I can say that with regard to the submissions that we had at this year's conference, it was definitely, if not number one, it was number two with regard to the number of presentations submitted and the level of interest. So, and a number of announcements were made at the conference and all, so it was definitely right up there. So there's a huge, huge wave in the industry, and there's unquestionably that. But I think that and persistent memory were probably the two key things at this year's Flash Memory Summit.
I had a question. This one is SAS versus NVMe versus the various approaches of PCI and NVMe in particular. What is going to be the future going to have one interface? Are we going to, protocol? Are we going to have, will both survive? Will one survive? I'm just curious to find out, to get your impression of that.
My view is that we'll both survive for an extended period of time. I don't know if there's going to be a convergent, 10 plus years from now, but in the short term, I think we're going to run in parallel for a while.
I guess maybe we need to define what survive means.
Well, they flourish.
If it's flourishing new instances, I see PCIe as being sort of the dominant in storage for new native applications is kind of what I would see. It's kind of my thought is if both standards end up being at complete feature parity and PCIe is just built in to every SoC, every CPU, what becomes the benefit of the added cost of doing SAS at that point? If I need to do new hardware, new design, why would I do it on where it's the there's sort of this PCIe? It's not just about storage. So you have networking, you have graphics pulling that standard forward continuously, and storage kind of gets to draft onto that. But again, it just depends sort of on that feature parity and the trust and that maturity when that happens at what point. So that's sort of my view, and I think it's exciting that there's two sort of pushing each other.
I just want to get a little juice going.
Yeah.
Yeah.
And one question I often get with PCIe Gen 4 and 5 coming only about two years apart is, well, maybe I'll just skip Gen 4 and I'll just go straight to Gen 5. And I think we're also going to see within the PCIe ecosystem, Gen 3, 4, and 5 solutions coexist for quite a while, because going to Gen 4 from Gen 5, the signal integrity issues get more challenging. Like you don't get as long a lengths before you need to use a repeater. And Gen 5 is just going to get even worse. So if you don't absolutely need that performance, why would you spend the extra cost in the design, the validation, and extra retimers if you don't need it? So you might skip to a Gen 5 capable platform, but will you run your SSDs actually at Gen 5? I'm thinking in a lot of situations, probably not. And then there might still be cases where it's, again, a Gen 5 capable platform that maybe you're using that for your networking, but you're still running a lot of your storage at Gen 3 as well. So I think it's going to be pretty interesting even within the PCIe ecosystem of what speeds everything's actually running at.
Yeah, that's probably a pretty reasonable observation, because not every application is going to need the super duper capabilities. So, and also, I guess an argument for NVMe not necessarily taking over the world, well, you've got resources that you're using up in order to support that storage. While if you've got like something like SAS or SATA, you've got something that's a step away from you, and it's not eating up the resources directly on the PCI Express bus, for example. So there's an argument to be made for moving that away from your local bus and the kind of resources it's taking up memory-wise and stuff. So there's always arguments to be made both ways. Any other thoughts or comments? Great, well, thanks very much.